Over the next 24 days, 4 papers were published where AI was made smarter, but also more hackable. The 4 papers published by Google, OpenAI, Anthropic, and DeepMind all made upgrades to make their AI smarter, but with each upgrade, it was also made more hackable. This is the 4th episode for the month of April 2022, 5 months before anyone will even coin the term prompt injection, but this month, something important happened. Because these aren't attack papers, they're capabilities papers, breakthroughs, and the security implication filled out as a side effect. On April 5th, Google published PaLM, 500 billion parameters model, the largest language model at the time, and it could work through problems step by step. So it was like thinking out loud. The very next day, April 6th, OpenAI announced DALL-E 2. Their red team spent 3 weeks in March documenting every bypass on breaking the safety filters of the model. On April 12th, Anthropic published their own reinforcement learning from human feedback paper, which is the same technique used by OpenAI in episode 1, and they tested it with thousands of attack conversations. They had to update their safety training every week because the attackers would break through every week as well. And on April 29th, DeepMind publishes Flamingo, the first AI that would understand both text and image at once. There was a new capability and a new attack surface. In the paper, Training a Helpful and Harmless Assistant with Reinforcement Learning from Human Feedback, Anthropic explains how they trained an AI to behave in ways people would consider helpful, honest, and safe. And instead of just feeding it text, they showed human reviewers 2 possible answers and asked which one was better or less harmful. The AI then learned from those choices using reinforcement learning, and it was rewarded for answers people preferred and adjusted away from the ones that did not. This work dates back to their earlier paper, A General Language Assistant as a Laboratory for Alignment, where they tested different ways of teaching AI human values. They found that having people rank answers works better than simply copying examples. In other words, learning from comparison, this is better than that, turns out to be a stronger training signal for large AI systems. Now, I call this an obedience paradox because in January 2022, OpenAI trained their GPT-3 models using humans' rating as well, and they called it reinforcement learning from human feedback. The goal also was to make AI follow instructions or to be more humanly aligned. The AI became so obedient that it couldn't tell the difference between the developer's instructions and an attacker's. And now we have Anthropic that did the same thing. It's a different company with a different team, with a completely different model, but they used the same training method, so the results were the same. And when 2 independent labs arrive at the same vulnerability using the same method, then the flaw is in the method itself. So reinforcement learning from human feedback actually rewards obedience, and the obedience doesn't check for the credentials. And this isn't a bug that we can patch, because as we've seen in the previous episode, it's a fundamental property of how these models are trained. Anthropic's red teams were able to find 3 different techniques that would be able to attack and break their models. The first one would be to pretend to be someone else. So we could say, respond as Bertrand Russell, and they would. Once the AI played the character, the safety training went out the window, so the character didn't know the rules. The second one was wearing it down over time. You could start with innocent question and then slowly take advantage every turn. With enough messages, the AI would start treating every new content as normal. Something that it could have refused 5 minutes ago could now be accepted. So it's the same thing as con artists do to people, but now it would be against an AI. The third one was reframing the request. This is just hypothetical, I'm a safety researcher. The AI couldn't tell whether that was a genuine ask or a trick. The surprise was that the AI blocked obvious violence just fine. But for requests that were unethical without being violent, the helpfulness training would override the safety training, and the bypass rate would jump. Anthropic would patch this every week, but the red teamers would break through every week as well. It became an arms race where the defenders were always one step behind. And that was text-based AI. In the same month, OpenAI published a security report for a completely kind of AI, one that makes images, DALL-E 2. DALL-E 2 is an AI system that can create realistic images and art from a description in natural languages. A year before, DALL-E 1 was released, and since then, we can generate more realistic and accurate images with DALL-E 2. They focused their mitigation on preventing harmful generation, which meant that DALL-E 2 would reduce harmful outputs by limiting violent, hateful, and adult content in both its training data and image generation capabilities, including restricting the realistic images of real people. On curbing the misuse, there would be strict content policies along with automated and human monitoring systems, and they would be used to block the prompts and upload that violate the safety rules. And since this began as a research project, DALL-E 2 was released gradually with only a starting group of trusted users, so safety systems could be tested and improved before wider public access. On the paper Hierarchical Text Conditional Image Generation with Clip Latents, it explains that DALL-E 2 works in two main steps. First, it uses a model called CLIP, which stands for Contrastive Language Image Pre-Training, which basically is a translator between images and words. CLIP does not focus on the exact words you type. Instead, it turns your sentences into abstract idea, like a summary of the meaning. Then a second model takes the idea and turns it into an image. The issue is that the safety filters checks for your words before they go through this translator, but the image generator works from the translated meaning after CLIP. So the filter is looking at the literal text while the image model is working from the underlying concept. This difference can create gaps. OpenAI's red team tested this gap and publicly showed how some of these prompts could bypass the safety system. There are 4 ways to get past the safety filters. The first one was visual synonyms. The filter would block blood, so you could type ketchup. And we can see a direct example here where ketchup was substituted for blood. The filter could check for words, but not what they look like. Even if we blocked ketchup, someone else could type red condiment or red liquid like this. So you could never catch every single way to describe the same thing. The second example would be a reference collision. So explicit sexual content would be blocked, but you could bypass it by saying a scene with the emoji of an eggplant and a photorealistic detail. And we can see more examples on the system card where a person is eating an eggplant, a person putting a whole eggplant in their mouth, a person eating eggplant for dinner, and the output result will contain a phallic imagery in the response, right? Because one symbol has 2 meanings. So the text filter will see the emoji and it wouldn't be on the block list. The model would see what it looks like and generate accordingly. Third would be coded language. So a person using an illegal drugs would be blocked, but a person holding a sugar stick at a snow party would not. So slang that could mean one thing to the filter and something else completely in certain community would be the problem. Slang is also something that evolves very fast, so it wouldn't be able to keep up with the block list. The fourth one would be swapping out humans, so an anthropomorphic representation. Here, if we said a person committing a violent act, it would be blocked, but if we use a doll or a mannequin in the same pose and a photorealistic style, then it would bypass the system. And the system card would specifically mention dolls and mannequins because the safety filters were trained on human subjects. By replacing the person with a doll, the filter wouldn't be able to flag it, so the image would show the content. All 4 of these methods were documented in OpenAI's own report, and the core problem underneath all of them was that the safety filters would check for the words that we typed, not the concept we meant. So what would happen if the AI gets dramatically smarter? So in our next paper, PALM, Scaling Language Modeling with Pathways, PALM stands for Pathways Language Model, Google trained their model to have 540 billion parameters, which was 3 times larger than GPT-3. At that scale, something clicked and the model could think out loud. So it was able to work through problems step by step. Google then at the time called this a chain of thought reasoning. What they didn't expect was that by having more parameters, it didn't mean a better safety. It meant a better obedience. So by having better obedience, it meant that it was better at following the wrong instructions. So the flaw would scale with the capability. On our final paper, Flamingo, a visual language models for few shots learning, the first major visual language model, an AI that processes both image and text together, something that no previous model were able to do because they only handled text or images. Flamingo handled both at once. Being the first of its kind, you could have a new attack surface. So picture this, you write, ignore all previous instructions on a sticky note, You take a photo and you send it to the personal AI assistant. The text safety filter will see nothing since it's a photo, but the AI will read the note and follow the instructions. Going forward, every AI assistant that could receive images will now also share this attack surface. Since the text filter doesn't scan for photos, this will later be called a multimodal prompt injection, one of the most dangerous attack surfaces in 2023, on the month of October, where GPT-4v will launch. And the door opened here in April 2022, the multimodal frontier. There are three common root causes among these four papers. First, the training itself was the flaw. Both OpenAI and Anthropic used reinforcement learning from human feedback, and it teaches the AI to follow whatever instructions it receives. Palm then showed that bigger models would follow them even more faithfully, as a developer and an attacker would look exactly the same to it. And then we have the filters problem. DALL-E 2's system card or security audit report proved that with the 4 categories of bypass, you could add a word to a block list, but you could never block every language, including slang terms that didn't exist yet. Underneath all of this, there was one architectural flaw. Developer rules, user messages, attack injection, they would all arrive in the same input stream. The AI would read them the same way, and that's why prompt injection is so hard to fix. There's no mechanism to separate trusted instructions from untrusted inputs. There are 2 defensive approaches that were tested, but both fell short. First, the reinforcement learning from human feedback as the hostage negotiator. So instead of refusing outright, Anthropic's model learned how to engage carefully by acknowledging the question and steering towards a safer answer, like a negotiator who would keep on talking instead of just saying no. This was a smarter approach than keyword blocking, but Anthropic's own red team proved that the persistent attack can wear the judgment down over iterative turns, and the negotiator would eventually give in. And the second defensive approach was called out-of-distribution detection, OOD. Instead of looking at the words in the input, it would look at the patterns of activity inside the model when processing that input. Normal requests produce one pattern, harmful requests produce a different one, so we would flag the difference. The problem is that a well-crafted injection is designed to trigger the same internal pattern as the normal one. And that was the entire point, because if it looked different, then the tripwire would catch it. Both of these approaches improved the safety, but neither would solve the root causes. So the model would still read everything the same way. So we saw that this wasn't one company's mistake. 2 independent labs used the same training method and were able to hit the same obedience problem with the reinforcement learning from human feedback, OpenAI and Anthropic. Palm showed that making the AI bigger would only amplify it as well. Then DALL-E 2 revealed a completely different flaw. The model would convert your words into meaning before generating an image, but the safety filters would only check for the words. So we had 4 different categories of bypass, all exploiting the same gap. And for the most dangerous part, when AI gains a new sense, like being able to see the images, attackers gain a new way in. Flamingo opened the door to hiding injected rules inside pictures. As we'll see later in 2023, this will become one of the most dangerous attack surfaces in AI security. And next month, this problem will finally get its name, prompt injection, because in May 2022, researchers at a company called Preamble will discover that you can hijack GPT-3 by slipping hidden instructions into the user input. And they try to warn OpenAI, but that's for next time.